Okay, guys, my whole part 2 was I didn't have the right screen up for y'all. So I mean, you could see me working it out on the notebook, but you couldn't see actually the practice problems. So what I'm gonna do is I'm just gonna upload this as part 2 instead, and you can kind of see the mistake I made already. But the problem was 2 cosine squared negative 17 pi over 12 minus 1. So it was a cosine double angle formula, and it came from my formula sheet. I use my pen instead. So basically, I just had to do 2 times the 17 pi over 12, but it was supposed to be negative 17 pi over 12. I didn't write that on my paper. So it should have been negative 17 pi over 6. And that's what I did here. I had put in positive 17 pi over 6. So you can see that mistake I made. But then negative 17 pi over 6 lands in quadrant, let me see, 12, 18, 17. I had wrote it in quadrant 2. Technically it's quadrant 3, but because it's cosine, it's still negative. So my answer of negative square root of 3 over 2 was still right. So that's number 13. My simple mistake, though, look, cost me 2 out of 4 points. So be careful there. Okay. Number 14 was a double angle formula. So you had to select the right formula first and have to plug all this in. It was just select. And so then I just found out what they were. So 7 pi over 3 is back in quadrant 1, which I just wrote pi over 3 because it's the same thing. 7 pi over 3 is the same thing as pi over 3, and tangent of pi over 3 is square root of 3. So everywhere I saw that, I had to enter square root of 3. 7 pi over 4 is in quadrant 4, and tangent of pi over 4 is 1. So because it's in quadrant 4, it's negative. So then just plugging it in, I had to pick D because that's the one that matched the formula. Square root of 3 plus negative 1, and then 1 minus square root of 3 times negative 1. And then the last part was just to simplify. And right here, this negative square root of 3 times negative 1 just became a positive right there. So that's that one. Number 15, I did on the next page because I needed room. And this one, I really wish I could have seen me actually work it out. I'm going to upload it up here too so you can see me work. But at least this one, I'll call this one part 4, would be where you can actually see the problem to connect to the work. So the problem started out with square root of 2 sine times 2 theta minus 1 equals 0. So I solved it and got 1 over square root of 2. Sine is positive in quadrant 1 and 4. And I know to get 1 over square root of 2, it's a pi over 4 angle. So it's pi over 4 in quadrant 1 and 3 pi over 4 in quadrant 2. So it actually had to be 2 triangles. So if you would ignore the dividing right here, it would be 2 theta equals pi over 4 plus my period, 2 pi k. And then the other equation is 2 theta is equal to 3 pi over 4 plus my period, 2 pi k. But you have to solve for theta, so I had to divide everything by 2. So that theta is pi over 8 plus pi k, and theta is equal to 3 pi over 8 plus pi k. Okay, but when you divide, sometimes you can cancel one of these out. If I can get this number by adding these two things, then I only need the first equation. So I checked that out. Pi over 8 plus 1 pi, which is the same thing as 8 over 8, is 9 over 8. So I didn't get 3. So I knew it had to be 2 equations, which is why I chose B over here. Okay, so pi over 8 and 9 pi over 8 are my 2 answers from this side. I can't add 8 again because then I would get 17, and 17 is bigger than 2 pi. 17 over 8 is bigger than 2. So then 3 pi over 8 is my first answer. 3 pi over 8 plus 1 pi is 11 pi over 8. Again, I can't add 8 because that would be bigger than 2. So I just have those 4 answers right there. That's number 15. Number 16 It's pretty easy. They already give it to you. So if you're using your formula sheet, this is the same thing as alpha minus beta. So that's why I had to choose this one. And on my paper, I actually did it. My double negatives both became positives. So I got 2 pi over 12, which is the same thing as pi over 6. And so for part A down here, that's why I plugged in cosine of pi over 6. And then cosine of pi over 6 is 3. Square root of 3 over 2. So that one was pretty easy. Number 17 is one you might want to watch the part 2 or so that you can actually see me work the whole thing out. So cosine negative cosine plus 1 is equal to 2 times sine squared theta. You can't solve unless they're the same trig function. So I rewrote sine squared theta, it's a Pythagorean identity, as 1 minus cosine squared theta. So then we distributed the 2, and I got 2 minus 2 cosine squared theta. And then I moved everything to this side. So this negative 2 became positive 2 cosine theta minus cosine squared, and then 1, bringing this 2 over, minus 2 is negative 1, equals 0. So then I replaced cosine with x. So I got 2x squared minus x minus 1 equals 0. Came over here and did the magic x. Two numbers that multiply to give me negative 2, but add to give me negative 1 are negative 2 and 1. But then I had to divide by 2. So I got negative 1 and 1/2. So cosine equals 1, which because it's not bigger than 1, I can use this because this happens. And then cosine equals negative 1/2. So cosine equals 1 first. Cosine, same thing as x. So that happens right here at this point. That's angle 0. That's how I got this. Secondly, cosine equals negative 1/2 at a pi over 3 angle. You can see that from this triangle right here. And because it's negative, it happens in quadrant 2 and 3. That's 2 pi over 3 and 4 pi over 3. So this one had 3 answers. Okay, 18. You had to do the sum of two angles formula. So they gave us this 13 pi over 12. So you need numbers that'll simplify. So I used 10 plus 3 gives me 13. So 10 over 12 is the same thing as 5 over 6. And 3 over 12 is the same thing as pi over 4. So this is alpha plus beta. So that goes with this formula right here. So then I actually had to find them. So pi over 4, I knew everything would be positive. And I know that both cosine and sine, or 1 over square root of 2. So I went ahead and put those in for beta. Cosine is 1 over square root of 2. Sine is 1 over square root of 2. For 5 pi over 6, that is in quadrant 2. So sine is positive, but cosine is negative. So this one was positive, this one was negative, and it was of a pi over 6 angle. So sine is 1 over 2. Cosine is 3, square root of 3 over 2, but it's negative. And then you just multiplied. 1 times 1 is 1. Negative square root of 3 times 1 is negative square root of 3 over common denominator of 2 square root of 2. That's what I plugged in. Okay, number 19. This one you might want to go back and watch me work too. It's the ones you put in your calculators. So you need to make sure that your calculator is in radians for these. And if you happen to forget that, just look at the problem. It says type your answer in radians. So right here, you know it has to be in radians. Okay, so tangent, you got to figure out where is tangent positive. It's positive in quadrant 1 and in quadrant 3. So this one is the same thing as theta. This one is pi plus theta. So this one I just plugged in theta equal that. And then I just did plus pi and got the second answer round to the nearest 4 decimal places almost. Okay, number 20. No, it's all selected. Okay, if you look at the problem, it says 2 pi over 3 plus 3 pi over 4. The first thing I had to do was select the correct formula. You'll have a formula sheet. Then I had to plug in what those values are. So first I started with 2 over 3. It's in quadrant 2 right here. Okay, so I knew that sine was positive, but cosine was going to be negative. So this one is positive, right here, I knew this one was going to be negative. And then just what is the two angles of pi over 3. So sine of pi over 3 is square root of 3 over 2. Cosine of pi over 3 is 1/2, but it had to be negative. The second answer was 3 pi over 4. So again, cosine is negative, but sine is positive. But it was a 3 pi over 4 angle. So they were both 1 over square root of 2. One was just negative, the other one was positive. So then you just multiply and get your answer. 1 times square root of 3 is negative square root of 3. And negative 1 times positive 1 is negative 1. Over common denominator 2, square root of 2. So, but notice in the problem, I had to type in my work and my answer. Sometimes they don't ask you to completely simplify the answer all the way. You just have to do the first part. So it's a little bit less work on those. Okay, number 21. This one's super important because I explained why we just needed one equation, but still had two answers. And for this one, you'll see it says I got it wrong. I accidentally, before I click to the next one, I accidentally clicked there is no solution, even though I had typed in this right answer. So I still missed these points. So when you're double checking your test before you submit it, I would definitely check and make sure it didn't do something like that to you. Okay, so for this one, it wants to know when is tangent theta 1 over square root of 3. Well, first of all, tangent is positive, so I knew it was in quadrant 1 and quadrant 3. Okay, and then tangent is 1 over square root of 3 at a pi over 6 angle. So here it's pi over 6, but down here it's 7 pi over 6. So normally we write two equations out, right? But tangent's period is pi. And if I do pi over 6 plus 6 over 6, I get 7 over 6. So because I can get this second answer from this one equation, I only need the first equation. I don't need two equations. Tangent normally always works out that way. So my answer was A, pi over 6 plus pi. But then the final solutions part was still those two answers, pi over 6 and 7 pi over 6. But I can get them first from this one equation. Okay, hope that makes sense. Almost done. Okay, 22, I had cotangent squared x minus secant squared x over cotangent x cosecant x. So this was a difference of perfect squares, so I can split it up. What do I square to get cotangent squared? Cotangent. What do I square to get secant squared? Secant. So then you add them and subtract them. Okay, so then these two would cancel out, and you would be left with cotangent x minus secant x. So it's just picking the one that matches that work, and it's A for that one. Okay, number 23. This is the last one I did on part 2. So right here, I was just reminding you that anytime you have an inverse function, that is theta. So this is basically the same thing as cosine 2 theta. This is theta right here. So using my formula sheet, cosine 2 theta is equal to cosine squared minus sine squared. And you can use whatever formula you want. I just used this one. Okay, so I had to finish writing it out. So it was positive, so I drew in quadrant 1. I knew that opposite and adjacent were 3 and 7. 9 plus 49 is 58, so square root of 58. And then I plugged them in. Cosine would be 7 over square root of 58, but we got to square it. Sine is 3 over square root of 58, got to square it. So we got 49 over 58 minus 9 over 58. That gives me 40 over 58, which simplified to be 20 over 29. Okay, 24, and the rest of them all worked out in part 3, so y'all can go watch that when you have time. All right, guys, have a good day. Sorry that it's so many parts and so long, but it's just the way it worked out.